1652, it says determine the velocity and acceleration of the slider at C as a function of theta. So this is a slider, and at C we have to find the velocity and the acceleration as a function of theta. And it says use x coordinate to express the motion of C. The C, it moves to this horizontal guide, and empty set symbol coordinate for CB, and x is equal to 0 when this angle of empty set is equal to 0. So in this we have to find it in form of theta, and this is a diagram which they have given us, in which there is a point A, B and C. There is a slider and it moves horizontally to this horizontal guide, and there is a specific angle made with the horizontal of theta and this empty set, and the length of CB is L, length of AB is B, and the angular velocity at A is clockwise. So let's move to the solution. So over here we know that x will become 0 when empty set is equal to 0. So first we break this diagram into simpler shapes, where this is C, B, and the distance between them is L, and this angle is empty set with the horizontal. And over here between B and A, the distance is B, and the angle with the horizontal is theta. Both of them are right angle triangles, so we can use the trigonometric ratios over here. So we have to find the length of x, because that varies with the angle, and that varies with the point C. So the point C on this slider, that varies because as it moves to the horizontal guide. So this x is equal to L plus B minus, in bracket we put L cos empty set plus B cos theta. So we have taken the horizontal components of these two lengths CB and AB, because the movement, the direction we're taking is the horizontal for x, because the movement of point C is horizontal. And also mathematically you can see that when x is equal to 0, the angles are also is equal to 0, which means that cos theta and cos empty set both are is equal to 1, which makes L plus B, and when we subtract them from L plus B, they will automatically become 0. The equation automatically becomes 0. So that's why this equation we derived is correct. And the second equation we have used is L sine empty set is equal to B sine theta. This is the vertical distance. So however you move point C throughout the horizontal guide, the vertical distance from the base will always be same for B. And as you can see that the B is the vertical point for both L, AB, the CB, and also the B section, which is the AB section. So the perpendicular distance for both the triangles we have made will always be same for whatever the angle is, it doesn't matter. So that's why they both will be equal. And then we further substitute into sine empty set is equal to b over L sine theta. So this is our equation number 2. And as you can see, the vertical distance of A to B and C to B is equal, like the vertical component, if we take of both of them, the line L and B, it will always be same. And as you know that we are finding the velocity at C, and the distance traveled is x. So the displacement in the horizontal guide is x. So differentiating it with respect to t means that we are finding the velocity. So we differentiate x with respect to t. So we get dx over dt, which is equal to vc. And then we take this whole equation we formed, the equation 1 of x, and differentiate it. In this, L and B are both constants, so they will be equal to 0. And the remaining term, L cos empty set plus B cos theta, we differentiate that, but as it is with respect to t, so we have to use the chain rule. So when we are using the chain rule, we get negative, and in bracket L d over d empty set cos empty set dot d empty set over dt plus b d over d theta cos theta dot d theta over dt. This is the chain rule we have used over here. And then in the next equation, you can see the minus sign is gone because the differentiation of cos is always negative sign, and that negative cancels the negative out. So we get the equation L sine empty set d empty set over dt plus b sine theta d theta over dt. So over here we have to remove the empty set symbol because we need an equation in form of theta. So to do that, we use the equation number 2, which is sine empty set is equal to b over L sine theta. That will replace sine empty set. And to differentiate the empty set in the differentiation d over dt, we replace that with sine inverse b over L sine theta. So as you can see on the side, that if we differentiate sine inverse theta, we get 1 over under root 1 minus theta square. So over here, we do the differentiation over here. So we get b sine theta, in bracket we get b cos theta divided by under root L square minus b square sine square, and over here is omega because d theta over dt is omega, and then over here d theta over dt again, it will be omega b sine theta. So d theta over dt was over here because we were differentiating with respect to t, and we have to use the chain rule, and we use the sine inverse thing to differentiate this. So it is a bit of calculus over here. So using the chain rules and also the how to differentiate inverse trigonometric ratios, so we use that thing to differentiate this, and we get velocity at c in as a function of theta is equal to b omega, and in bracket it's b sine theta cos theta over under root L square minus b square sine square theta, and then plus sine theta. So this is a simplified equation we get after differentiating the x. Now we have to find acceleration at c. So to do that, we have to differentiate v, which is velocity. So differentiating velocity with respect to t, we get acceleration. But as you can see, the velocity equation is a bit complicated to be differentiated. So we break down the d over dt into dv over d theta multiplied by d theta over dt. So it is a kind of chain rule over here. So we're using chain rule to simplify our equation. So d theta over dt, as you know, is omega, which is the angular velocity, and it is multiplied by dv over d theta. So in this, we don't have to use the chain rule while using the differentiation, because we are already differentiating it with respect to d theta, because we have used the chain rule in the start of the equation. So AC is equal to WD over d theta, and in place of V, we put this over here, and then we differentiate it. And over here we can see that B, omega are the constants, so we take them out, and then over here we differentiate this part. And as there is a plus sign with it, so we can differentiate them separately. So d over d theta sine theta, it is simple, as the differentiation of sine theta is cos theta. But over here it is in form of a fraction, so we have to use the quotient rule. So in quotient rule, what we do is that the bottom part is considered as v, the upper part is as u. So we take two terms and we consider them as u and v, and then we use the formula over here, which is dv, and then multiply with the differentiation of u minus u, and then differentiating of v and all the terms over v square. So over here, after differentiating all of it, we get these values. And as you can see on the bottom, it says r square minus b square sine square theta, and its power is 3/2. It's because when we differentiate it as a form of under root in the numerator, there's a square root which is dividing with all the terms. So when it comes down to denominator, it reduces the power of square to 3/2, and then we further simplify this equation by multiplying 4 cos theta with the other term, and then we simplifying it with sine b square sine square 2 theta, and then in the end we get a is equal to b omega square, and in bracket we get b cos 2 theta plus b square sine 4 theta, which is the power 4 divided by l square minus b square sine square 3/2 plus cos theta. So this is a final answer. But in this question, we have to keep in mind to be really careful while using the quotient rule, and keeping in mind that there are a lot of alphabets which the symbols we're using, so we have to keep in mind what we are differentiating with respect to, which is theta over here. So any other variable which is L, B, we have to keep them as it is because they are considered as constants. So we have to be really careful about that, and it will be much easier to do these questions if you know the trigonometric identities like sine 2 theta, if it is sine cos theta, so it can be written as 1 by 2 sine 2 theta, as you can see over here. So it simplifies the equation really much. So knowing the trigonometric identities and basic trigonometric ratios, how they are differentiated, it becomes really easy to do that. But there are like certain steps where you have to keep in mind to be really careful while solving these type of questions, because there's a lot of chance to get error while doing this.